Hi everybody, I'm Professor Rad, and today we're going to talk about parameters and statistics, as well as some notation that we use for those. So in the first video, we talked about the difference between a sample and a population, and in the last couple of videos, we looked at some different ways that you can find samples that will hopefully represent your population pretty well. So when we are studying data, it's going to become important to know whether or not the information we're looking at comes from a population or whether that information came from a sample. So if something comes from a population, we're going to call it a parameter. And if it comes from a sample, we're going to call it a statistic. Now, this is really nice that they named them this because both population and parameter start with P, and both sample and statistic start with S. So if I want to identify whether or not the value I'm looking at is a parameter or a statistic, I first have to look at who does that number describe. Does it describe something that came from a population, or does it describe something that came from a sample? So let's look at a couple examples of identifying parameters and statistics. So for example 1, it says, according to citydata.com, 22.3% of the residents in Utica have Italian ancestry, 9.3% have an Irish ancestry, and 8.5% have a German ancestry. So let's identify whether this is a parameter or a statistic. Now, percentages in particular tend to be the trickiest ones to identify because when I see something like 22.3% of the residents have Italian ancestry, I think, well, 22.3% isn't everybody, so it's a sample, so it's a statistic. And if I think that way, I would be wrong. And here's why. That number, 22.3%, that's what we're trying to classify. How we classify that number is based off of where that number came from. It's a percentage of the residents in Utica. So they got that percentage by looking at all the residents of Utica. And when they looked out of all the residents, this is the percentage they found with Italian ancestry. So this group is a population, and therefore the value, 22.3%, is a parameter. And same thing with the 9.3% and the 8.5%, because these percentages are all taken out of the same group, out of all the residents in Utica. Let's look at this second example to see how a percentage might be a sample or a statistic value. So it says, in a pay scale survey of 68,000 workers, it was found that approximately 62% of criminal justice majors said they were underemployed after graduation, whereas about 23% of civil and environmental engineering majors reported being underemployed. So again, we have some percentages, 62% and 23%. So we want to know where those numbers came from. So we have 62% of criminal justice majors and 23% of civil and environmental engineering majors. Now here's where we have to be careful, because this criminal justice majors and civil and environmental engineering majors, that group of people came out of a survey of 68,000 workers. So that came out of a sample, and therefore it's a statistic. If they didn't tell us this, if they didn't say in a pay scale survey of 68,000 workers, if it just started by saying, hey, guess what, 62% of CJ majors are underemployed, then based on that context, we would have identified this differently. Just like up here, it says according to citydata.com, and we're going to presume that they looked at all of the ancestry data of the residents in Utica. So there's our population. Versus here we have a survey that's going to tell us it's a sample or a statistic. So again, this is one of the things that can be challenging about a statistics course, is you have to read very carefully And you can't always just say, I always do this. I can't always look at that of number. I also have to look for additional context cues in the sentence. Now, in statistics, we'll do some more examples of those in a moment, but in statistics, I want to talk about two numbers that we're going to use quite a bit. So two of the numbers we're going to use in this class are called the mean and the standard deviation. Now, you probably already know what the mean is. The mean is when you take all the numbers in your data set and you add them all together and you divide by however many there are. The mean is what we usually think of when we think of an average. Standard deviation is going to tell us kind of how information is spread out. So for example, maybe the average temperature in a city is 68 degrees, but over the course of a year, the temperature ranges from like 10 to 100 degrees. Oh, excuse me. Perhaps another city has an average temperature of 68 degrees, but over the course of a year, it just ranges from like 50 to 70 degrees. So in that situation, one of those cities has a wider range of temperatures than the other city, and the standard deviation is a number that kind of clues us in to how big that interval is going to be. So when we are studying information about the mean and the standard deviation, we're going to use different symbols depending on whether it's about a population or whether it's about a sample. So if our data is a parameter, remember parameter means it comes from a population, we're going to use Greek symbols. I don't know why, that's just what they chose to use. So for the mean, we're going to use the Greek letter mu. So it kind of looks like a U with a really long edge on the left, or kind of like an M where the right-hand side is shorter. And the way that we say that is mu. For the population standard deviation, so to tell us how far out the data gets spread, we're going to use the Greek letter sigma. And this is a lowercase sigma. There's also an uppercase sigma that we'll use a little bit later. So we have mu and we have sigma for population values. When we have sample values, so statistics, we're going to use some more usual looking symbols. So for standard deviation, we're going to use an S. And for the mean, we're going to use a place where your former lovers go to have a drink. That's the X bar. So an X with a line over it, that's your X bar. And then S is just S. That's the pronunciation guide. So mu and sigma for mean and standard deviation, X bar and S for sample mean and standard deviation. So I've got 5 examples that we're going to look at. We will identify whether a value is a parameter or a statistic. And then we will also identify which of these letters, which of these variables we should use to describe that information. All right, so let's look at example A. It says, an orthodontist learns that a sample of 100 adults wear braces for a mean of 32 months. So what I'm going to look for here are 2 things. First, I'm going to be looking for, is this a sample or a population set of data? And secondly, is it for a mean or a standard deviation? So in this case, I'm noticing there's a sample of 100 adults. So a sample means that it is a statistic. Then the other piece of information we have here is that it's for a mean of 32 months. So over here in our little chart, we have a sample and we have a mean. So we're going to use X bar. So that means we would use X bar to represent that 32. So I might say something like X bar equals 32 months. Let's do another one together. So part B says that the mean price per square foot of hardwood flooring in the US is $9.50, not including the cost of labor, with a standard deviation of $1.83. Okay, so I'm noticing that it says the mean price, but it also has standard deviation. So for these problems, we're trying to identify what the bold number is. So in this case, the bold number is the 950. So that means it's going to be the mean price. For this problem, that $1.83 is not bold, so it's there just to mislead us, just to confuse us, you know. So because it's a mean, bring my chart back down here, the mean is either going to be mu or x bar. So it's either going to be mu or x bar, so I can eliminate these two. Then I have to figure out, is it a parameter or a statistic? So they're talking about the mean price of hardwood flooring in the US. So in example A, they told us it was about a sample of adults. Here, it's just about flooring in the US. So that's telling me this is a population. So this will be a parameter. And so in population, it's got to be either mu or sigma. So it's not x bar, which means it must be mu. So I worked through these two examples in slightly different ways because there are different ways that you can narrow down the solution for these. So kind of go with what leads you. In part A, I got excited because I saw the word sample, so I knew right away it was a statistic, and that sort of guided my thinking. In part B, I got confused because I saw both mean and standard deviation, and that sort of caused me to look in that direction first, and then try and figure out whether it was parameter or statistic second. So let's look at these next three examples. What I'm going to do is I'm going to ask you to pause the video, try these problems out on your own, and then you can unpause the video and my answers will be on screen and I'll talk through how I found them. But test your learning here. See if you can identify which of these are parameters or statistics and then which symbol we should use. All right, so hopefully you took a moment to pause the video and find your answers. And I'm going to go through and talk about how I found my solutions. So part C, I identified sigma, which means this would be a parameter. And I did that because the bolded number, $1.83, was about the standard deviation, and it was about hardwood flooring in the US. So we have a population standard deviation, and that would be sigma. For part D, this one is a statistic. And I chose S as the symbol to use. And that's because I noticed the doctor selected a sample of 20 16-month-old patients. So it's based off a sample, so it's a statistic. And then the bold number here, they gave me two numbers, but the bold number is the standard deviation. So here's my standard deviation for a sample is S. And lastly, I picked X bar. That one's also a statistic. And that's because Steve studies 100,000 red kangaroos. Now, honestly, I don't know how many kangaroos there are, but it did tell me that that's roughly 16% of the population. So here they're telling me that the kangaroos he studied is a sample. So that's how I knew this was going to be a statistic. And then that 1.5 meters was the mean height. So for a statistic that's a mean, I'm going to use X bar as my symbol. So this sort of identification can be a little bit tricky. It becomes easier over time and with lots of practice. You start to know a little bit more what to look for. So I recommend that you work on practicing identifying statistics and parameters. In the next video, we're going to start to do a few more things with actual numbers, and we're going to start looking at some graphs, some more descriptive statistics in how it's presented as opposed to how it's collected. So I'm looking forward to seeing you then. In the meantime, I hope you have an excellent day. Bye, everybody.